Uh, this is a small video that we're trying to build to offer some potential proofs for the indeterminate forms. You can check Wikipedia page that you see in the video, which actually gives you an introduction to some of the mathematical formulas which are considered indeterminate as per L'Hospital's rule. So let me actually start with the first proof that I would like to present to you. So we'll probably start with 0 to the power of 0. As you can see, actually 0 to the power of 0 is indeterminate as per the previous article. But you must have to follow an equality rule. So when it follows an equality rule, you can actually change the form to a minus a to the power of a minus a, which you can as well write it as a minus a whole to the power of minus a plus a. So you could just check that when we derive this particular form converts to a stage where a minus a to the whole to the power of a minus a is equal to 1 by a minus a whole to the power of a minus a, which leads to a resolution saying that a minus a whole to the power of a minus a is equal to root of 1, and obviously root of 1 is equal to 1. If you evaluate the left side of it, then you'll find that 0 to the power of 0 is equal to 1. So this is our fundamental proof for 0 to the power of 0, which is also one of the indeterminate forms. We will use this in our future proofs. So let us get to the second proof. And if we are really looking at 0 by 0 as another indeterminate form that we would like to prove, 0 by 0 can be written as 0 into 0 to the power of minus 1, because we are just trying to bring fraction portions, a denominator to a numerator, so we're just raising it to the power of a negative. So obviously this can be written as 0 to the power of 1 into 0 to the power of minus 1, and then you can add up the powers, so it results in 0 to the power of 0. We already have proven that 0 to the power of 0 is equal to 1 in the previous evaluation. So obviously 0 by 0 is equal to 1. So we'll be using these in our future evaluations of indeterminate forms. So let us get to the next indeterminate form. This is 0 to 0 multiplied by infinity. If you are looking at the definition of infinity, as per the calculus, we will find out that infinity is not a number, but it is generally written as a limit of 1 by x, where x tends to 0 plus, and 0 plus is greater than 0, but very closely tending to 0, but still positive. So using this definition of infinity, let us evaluate this expression. 0 multiplied by infinity can be written as 0 multiplied by limit of 1 by x, where x tends to 0 plus. So as per the formulas of limits, obviously a limit of a by b, where it can be written as limit a by limit b. So we're just trying to evaluate that expression, so it becomes like 0 star limit of 1, where x tends to 0 plus, divided by limit of x, where x tends to 0 plus. Obviously it's a constant in the numerator, so you can get 0 star 1 divided by limit of x, x tends to 0 plus. And just when you really try to evaluate the denominator, the limit of x, where x tends to 0 plus, becomes just a 0 plus, and you can divide that 0 with a 0 plus. Obviously anything that divides 0 will result in 0 as a result. So 0 into 1, that makes it 0. So obviously that means 0 into infinity is equal to 0. So let us move to a similar type of a proof, and the negative side of it. It just changes in terms of the sign, but it also results into a 0. So let's move to the next one. So the next indeterminate form we're going to look at is infinity to the power of 0. So just going by the previous definition of infinity, where again just following the same logic, which makes it 1 to the power of 0 divided by 0 plus to the power of 0, where 0 plus is greater than 0 but tending towards 0, very close to 0, but not really 0 yet. So anything to the power of 0 is obviously 1, so it becomes just 1 by 1, which is equal to 1. So this means infinity to the power of 0 is equal to 1. Let's get the next indeterminate form. So this is infinity divided by infinity. So we are just trying to use the same definition here. So it's now becoming as limit of 1 by x, where x tends to 0 plus, divided by limit of 1 by x, where x tends to 0 plus. So you can now use the formula of limit a by limit b is equal to limit a by b, and this results in limit of 1 by x divided by 1 by x, where x tends to 0 plus. So you just reverse the fraction in the denominator and multiply it with the numerator. So you can get, it's basically a 1 by 1, and it's just like a limit of 1 where x tends to 0 plus, which is actually a constant, so it's obviously 1. So you get infinity divided by infinity as 1 right now by using this evaluation. So let's go to the next evaluation. Well, this is an interesting one, and you may just wonder why you really have such a simple evaluation for such a complex logic of infinity minus infinity. So we are using the same definition of infinity. We're just taking fractions and using a standard formula of limit a minus limit b is equal to limit a minus b. So we're just using the same definition of infinity. We get like limit 1 by x minus 1 by x, where x tends to infinity, and just evaluate the fractions as usual. So we get a limit of 1 minus 1 divided by x, where x tends to infinity, which is 0 divided by x. We know that 0 divided by anything is equal to 0, so it should be. Limit of x basically becomes 0. As you see, 0 is a constant, so that means infinity minus infinity is 0. So let's get to the last and the most interesting of the indeterminate forms. So 1 to the power of infinity. What is 1 to the power of infinity? Obviously, you can right now use the first formula that we evaluated. It's 0 to the power of 0 whole to the power of infinity is equal to 1 to the power of infinity. We have already proven that 0 to the power of 0 is equal to 1. So by applying a simple formula of a to the power of a whole to the power of b is equal to a to the power of a into b, we are applying the same logic here, and we're trying to actually evaluate this power, and it becomes 0 to the power of 0 into infinity in the power. We already have proven this 0 into infinity also as 0 in the previous evaluation. So this becomes 0 to the power of 0, which is equal to 1. So that means 1 to the power of infinity is equal to 1. With all these proofs, it's very evident that all the indeterminate forms can be still evaluated, and we have predefined values. That ends the video. Thank you.